So I will elaborate a bit in the background since some of you in the future might work in engineering consultation companies. He will be benefiting from these backgrounds to know how to do the projects, engineering projects. Also, those are in industry. Sometimes they have partially some of these activities that we will discuss today. So what is R&D? R stand for research and D stand for development. So there is a terminology known as TRL, technology readiness level. So any technology start with the idea, then this idea will be researched to prove the concept, then developed until it is a pilot plan. Then we further develop until it is a commercial product through levels of TRL. So first is the TRL 1 to TRL 3. This is under the research category. Then TRL 4 to TRL 6 is the development category. After that, the final one is the deployment from TRL 7 all the way to TRL 9, which is ready for commercialized product. So TRL scale, starting from TRL 1, where you start thinking about the principle itself, how it works without any calculations. Then TRL 2, you will have the concept formulation. So you do all the calculation needed for the concept. TRL 3, you will do experimental or analytical mathematical approach, simulation approach to prove the concept, to know that it works actually. Then TRL 4, you'll do the validation and comparison with other studies, but still in a controlled environment, which is known as lab environment. It's not the actual environment. So these four under a category known as proof feasibility. So it is feasible, it is applicable. Then TRL 5, you validate, but in a relative environment, not the control environment of the lab, but in a relative environment. Then TRL 6, you'll have not the component, but the system. So you combine many components in your system. Then you do a prototyping for the system, not for the component, in also a relative environment, not the lab environment. Then TRL 7, you have the system prototyping demonstrated in operational environment. So a relevant environment is not controlled, but it is more close to the actual one. The operational environment is the actual practice, means you take this one to the industry, you take it to the rural areas, you take it to the environment that it is supposed to work in that environment actually. So no control of the environment whatsoever. So from TRL 5 to TRL 7, these stages known as the technology demonstration. So you demonstrate that this technology is operational. Then we finished already until TRL 7, which is technology demonstration. Next is TRL 8, actual system, not prototype. So if you have a smaller scale prototype, now you build the actual scale, but you do the qualification, troubleshooting, ironing some issues for operation, reliability, life cycle. TRL 9 is the last one, is the actual system proven in the operational environment. So you do a test run for some time in the actual environment and make sure that it works properly, is proven already. So these two TRLs known as the system launch. So you launch the system, you are ready to demonstrate it and bring it to the commercialization. Some phone companies, for example, they rush. They have a competition, so they rush. So they release some phones or some softwares to the customer, but it is still buggy. Too many bugs, too many problems. then they start sending these updates, firmwares, and so on. So they didn't actually do TRL 9. They just did until TRL 8, then they release. Then they, because the time constraint, there are other competitors that already released the competitive products, so they don't want to lose. So they skipped TRL9, but it's not good for their reputation. It's very buggy in the beginning, so they need to release software updates and so on to iron out all the bugs. So engineering product. So there are concepts known as EPCC. So E stand for engineering, P stand for procurement, which is the purchasing, C stand for construction, and the last C stands for commissioning. So the engineering is what you do here in your engineering design. You are in the beginning stage, which is known as the engineering design. So the engineering starts with the planning phase, then the basic engineering, which is just the schematics without the detailed engineering of stress analysis, thermal analysis, and so on. Then you will have the detailed engineering. Lastly, you have the budgeting estimation. Then for the procurement, you have the subcontractor for custom manufacturing pieces. There are two types of parts. Some are off the shelf, some are custom. So you need to start to find who can do that for you. Even big companies cannot produce all the parts for the system on their own. So they have to contract other people, vendors known as vendors, as a subcontractor to do those parts for them. So you need to start looking which are the parts you need a subcontractor and which are the parts that are supplied directly off the shelf purchases. Then you start the purchase itself, the procurement. Then you'll have receiving, logistics, PO, DO, transportation of the goods, and all that. Then construction phase, you'll have the mechanical phase, construction, you'll have the electrical construction, you will have the civil construction, even any project, even air conditioning or something, it will have the civil foundation for your air conditioning, it will have the mechanical part, construction, it will have the electrical part. So these are commonly in every project, you'll have these parts in your construction and installation. Lastly, the commissioning, firing the project, running the project, initializing the project. So commissioning is a general terminology, is very loose. Some will define it based on their terminology. Others will not include the operation, will include only the testing. So it is very wide terminology. Not everybody agree what commissioning actually means. So in general, we'll give you the general terminology. It starts with the testing, then operating the system, then maintaining the system. Then you'll have after sales services. You provide services for the customer after sales. Then you'll have the modernization. You improve the product. So sometimes the EPCC project final stage is commissioning. With testing, it stops. Just testing, then you hand over to other people. Then the other people will do the operation, the maintaining, the after operation services, and so on. So there is a contract known as EPC contract. It is given to a company, will be known as EPC contractor or also known as turnkey contractor. Why turnkey? Because they do the engineering until they give the other company or the mother company the product as a turn of the key ready. So they guarantee that it will operate and the mother company should receive this product and turn the key only, and it will operate. So this is one type of contracts. Many engineering companies take this type of EPC contract. They call it a black box. So they do everything. Then they give you the black box. The black box is turn off the key readiness. You just take it and operate it, or give it to another company to operate it. Then in between, there will be a company for inspection, of course. Then you'll have the contractor should deliver and guarantee the operation of the turnkey product by a turn of the key. So it should be a ready one. The APC contractor or turnkey contractor is usually not the operator of the project. Another company will be the operator of the project. So the mother company could be the government, could be a company, could be anything that contract the turnkey contractor. Then it could be also the operator, or give the contract of operation to another company. So, however, the turnkey contractor will do all EPCC, even the commissioning, as we mentioned before. But in this case, commissioning will be very limited to testing only. So they do commissioning, but up to the testing. Then the other company will come and take and do the operation and the maintaining and the after some time service for customers and so on. Other type of engineering projects for very large companies, if they want to do a new concept. For example, Toyota wants to do hydrogen car or EV, electrical car. So internally, they will initiate a new department. They call it hydrogen car or electrical car. They don't, in this case, usually they don't have a turnkey contractor. So this is a bit wider than the turnkey contract, the EPC contract. It starts from wider scope. So it starts from concept, all the way from concept. If this is a new concept, they have to study the concept. So they have to start from very low TRL scales, maybe scale 2, scale 3 even. So concept, then feasibility, then planning, then engineering. So engineering is the first stage in EPCC. After engineering, you have the procurement, the purchasing, then you have the construction, then you have the commissioning. Here you can see commissioning and operation are separated. This is the confusion in terminology. Commissioning in general, it should include operation, but in this type of contracts, in this type of engineering projects, it is separated. Commissioning means just testing. Then operating will be the lifelong operation. So this is the project. You have some overlapping between the phases. So concept will overlap with the feasibility by the end of it. So the concept is proven and calculated, maybe simulated. Then you will have the feasibility. Then you will have the planning. The planning started with the pre-planning, then the planning. Then you will have the EPC. EPC here does not include the commissioning. So it is engineering, procurement, and construction. Then you have the commissioning overlapping also with the planning phase. So commissioning will be this case the initial testing only, not the operation, lifelong operation, and after sale services. So engineering design phase, we are not concerned about EPCC in general, but you need to know about EPCC, even if you are in industry, not in consultation companies. Sometimes in industry, as we mentioned, the big industries can have EPCC as well. So engineering is the first part, which is we discussed here, engineering design phase, which is the E from EPCC. So the engineering design flowchart, you start with a conceptual design, followed by a definition, followed by detailed design. So this is under E, under the engineering design. So the conceptual design, you will have the planning and control. You will have a site utilities assessment. How is the site suitable for you? How is the utilities available? Electricity, gas, fuels, whatever utility, water available for you in this site. You need to evaluate assessment before you start. Then you will have the scope definitions. Then you will have the detailed discipline support, which is the documentary, the SOPs, and so on, to fix all these definitions, scope of work, and others. Then you'll have the phase completion. Definition phase is basically a revision from the conceptual design phase. You revise, then you define final definition. What is this? What is this? For each part. So you start planning and control. Then you will have the scope definition, which is a revision of the conceptual design scope. Then you will have the disciplinary support. In this case, is a bit wider. You need to start looking for your vendors. Who are the vendors, the subcontractors that you will need. You'll need also to start looking at the laws, DOSH requirement, Department of Safety requirement, any concepts, any standards you need to follow. So you need to prepare these in your definitions. Then you will have the phase completion. Lastly, you have the detailed design, planning and control. In the beginning of any phase, you do planning and control. You draw the Gantt charts for all the phase, starting activities, milestones, until the end completion. Then you will have the scope refinement. So this is after definition, you just do a revision, final revision, which is the refinement. Disciplinary support, you already know who are your contractors, you know what is requirement, all the documentation, legal, logistic, and everything, you know already what you need in your design. Lastly, you complete this phase. So this is a general design in any company. These are the general phases. So I will attach here a PDF file. The name is Engineering Design Plan. In this file, I will show all the documents that are needed to be supplied. So if you are a turnkey contractor, the mother company will ask you, once you finish the engineering design phase, for a certain documentation. Is a big list. So you have to prepare all these documents in this list to complete the design, engineering design phase. Then start the after the other phases. So the deliverables, the documentations that you need to provide. So first, the process, you need several documentations. So these documentations not necessarily used in this course, in this design capstone, but some of it will be also used, not all of it. This is general documentation that you need to deliver when you deliver your EPCC project, the E part, the engineering part project. So the process design calculation, this also you'll do in your capstone. Process and utility design basis, it depends on your project. Do you need to include the boundaries in your calculations or not? So utility are the boundaries. What are the boundaries of your design? Electricity input, water input, gas supply, whatever utilities are required, you design the flow chart for them. Then you have the process flow. Then you have the process flow diagram, which is PFD. Then the heat material balance, so the energy balance and the material balance. Utility requirement sizing for any supply support utility, the sizing for each utility. The boxes for three-phase supply of electricity. You need to install control boxes. So you need to purchase what size, how much ampere in each box, the cables that you need in your box. This is part of the utility requirement sizing. Then the utility flow diagram, UFD. This is a schematic drawing. This is very important. You'll do in your capstone. Utility flow diagram is basically the chart with lines with different colors. So steam in some color, air in different color, material in different color. Then you will have the boxes for reactor, the boxes for heat exchanger, all not drawn engineering drawing, but a symbol. So this is basically a schematic diagram with symbols, not with actual engineering drawing. Then you have to show every part go where, and if you have a bypass and going back and control a loop or not. Then you'll have the equipment line sizing, equipment and line sizing, if you have supply lines for gas, for air, and so on. Then you'll have the process line list, if you have many lines, for example, steam lines, air lines, water lines, you have to do the line list. Then the tie-in list. Tie-in means if you have a place in your line that you do the tie-in. You take from there to disconnect or for maintenance or for any person, for any purpose, you disconnect the line from there. You do the tie-in. So you do the diagrams for that. Then you have the flaring, the relief, the venting, the blowdown study. For any startup, for any shutdown, you need to show where is the relief valves for safety, where are the flaring ports, where are the venting ports, the blowdown. If you have a boiler, you need to do the blowdown for the boiler, and so on. Other documents include the piping and instrumentation diagram. This is the most important, P and ID. This is more detailed than the UFD. P and ID is a detailed diagram with the material, with the thicknesses, with properties. So you'll have the UFD, normal design flowchart, but in the down you'll have numbers, number 1, number 2, number 3. In each one will be defined everything, including material, temperature, pressures, everything you have to define in this P and ID. But control is usually not included. Control usually is additional document known as PID. So you can have P and ID plus PID, which is the proportional integral derivative. So this is the control schematics for each part. So if you have the boiler, you can have a special drawing called the PID of the boiler. So you'll have the relief valve, then you have the electrical control circuitry. When the temperature is this amount, this panel will shut off, then this pump will shut off, and so on. So you'll have the sequence. This is all drawn in a schematic known as PID. Then you'll have alarm, shutdown, and control set points. This is a document you need to provide. You'll have the process control and safeguarding philosophy. If you have a safeguard, any door opens, the process shut down. Any window you have in the process, if it is open for some reason, somebody stepped into the area of the operation, you have a safeguarding. So you'll have a shutdown procedure. So you need to do the control and the philosophy of the shutdown. Then you'll have cause and effect matrix. Probably you'll do this one in your capstone design, the cause and effect matrix. Then you will have hazard and operability study for hazards and for safety. Startup, operating, shutdown philosophy. These all documents you need to provide for your mother company. You are the turnkey contractor. You need to provide in phase 1 engineering. You complete. You supply all these documents for them to inspect. Sometimes they give another company the task of inspecting your work. So they would inspect each document one by one and will ask you, what is this? What is this? How is this operating? Why is this one 3 bar? Why is it not 4 bar? How do you know that it is enough or not enough? So the inspector will inspect each document in detail. Mechanical processes, you need to show the equipment layout and the elevation view, the different views and sections. Tie-in drawing, as we mentioned, if you have a line and you cut the line from some point, you have the tie-in drawing. Then the electrical diagram, you'll have the electrical design basis, line diagram, single phase, three phase, how much diameter, you'll have 50 mm, you have 10 mm, what is the amperage and what is the cross section of your line. Then you have the electrical design basis drawing. Lastly, the instrument, you have instrument and control philosophy. This is basically a description of the philosophy, how you do the control for all the instrument. Then you have the control and shutdown logic narratives, starting with this, followed by this, followed by this, the narratives for the startup and shutdown. So project management in general first, then we'll go to discuss the project management in capstone design. So project management in general first. What is project management? It is the use of specific knowledge, skills, and tools and techniques to complete a set of coordinated activities. So you have activities, you need to coordinate between them. So you need to be organized using your knowledge, your skills, and your tools for management of these tasks. So this is all within a stipulated time, very controlled time. Usually you do the Gantt chart. So each activity will take how long exactly time. This is shown in your Gantt chart. Then you have to deliver the project deliverables. So the deliverables should be very clear. You'll deliver these documents, you'll deliver this equipment, you'll deliver this operation. Then you'll have the milestones in each task. You complete this stage, this is a milestone. You complete another stage, this is another milestone to the customer. So the customer could be the government, the customer could be another company of the operation. So you hand over, you have the turnkey contractor. You give the customer, which is the operator. So then the operator will sell the flats, will sell the product, will do whatever. So the documentation for project management, the following documentation have to be organized for the project management. So first you will have the organization chart. This is the general documentation, your organization chart or O chart, the ranking, the hierarchy of your company, the responsibility levels from management to supervision to operational and so on. Then you'll have the project executive plan. This is basically a small report like you will do in the end of your design project. You'll submit a report which is almost similar like the project execution plan. So in this project, you'll start with the background, problem, methodology, then how you execute this plan. What do you do to solve the problem? What do you do to do this, the design philosophy, and so on, without many details here. So this is the project executive plan. Then you will have the design basis memorandum. So this is again will be not in detail, not with the calculation, just the design basis. Then you will have master deliverables registrar. This is the most important document. What are the deliverables that you are giving to the mother company? They should negotiate with you. What deliverables they will give, they will receive from you for the amount of money, for the amount of time of the contract. So you need to be smart. Don't put too many deliverables that you cannot complete in the time. So deliverables will include documentation in the engineering phase, will include product, will include services, will include many things. Then you'll have project management administrative matters. You need to report those documentations. You'll have the progress reports. In Capstone, you will have log sheets and so on. Here you'll have the plans, the notes, the progress reports. Then you will have the Gantt chart and the milestones for each stage. The measurement for each achievement, how you measure that. Then you have the minutes of your meetings. In any meeting, there is a secretary of the meeting who record the minutes of the meeting. Means whatever said, whatever decided in the meeting is recorded in a report known as the minutes of the meeting. Then you will have the local authority requirement, for example, DOSH, Department of Safety. So for pressurized vessel, if you have a pressurized vessel, you will need to report to DOSH. They have to come and inspect. Even if it is not pressurized, they say DOSH, even if it is the reactor is 6 inches and larger, you need to report to DOSH. So if you want to avoid DOSH, you are operating not pressurized, but you are operating too large, you still report to DOSH. You need to have at least 4-inch reactor, so you don't report to DOSH. So here we'll discuss about the specific project management for your course, capstone design. So how to manage your project properly, your capstone design project. In the beginning, you should clarify and define these things. First, your scope should be very clear. Your scope is basically your wall around the house. So the boundaries that you are working in. The larger the scope, the more difficult, the more challenging to achieve your project. So you should limit your scope to a certain definition, very limited. So the examiner will not ask you why you didn't do this, why you didn't include this calculation is out of my scope. My scope is this. So the scope is the wall around your house. Nobody asks you about what is outside. People ask you only what is inside your scope. So it should be defined. Then you will have the objectives should be very clear, what you want to do and how you do it and how you measure your success. So objectives should be defined with the word, what is the objective to design, to investigate. Then the methodology, how you do that, through calculation, through simulation, through what program, it should be clear. Then you show how you measure it, how you measure the success. Did you achieve this objective or you didn't achieve this objective? Then you'll have the strategy, planning, and task distribution. So you need to, as a team leader, you need to choose your members precisely based on their expertise, based on their strong points. Somebody is strong in SolidWorks, somebody is talented in MATLAB. So you have to distribute the correct task to the correct person. And you have to give a very clear strategy. It's not arbitrary. You need to plan properly. So this planning should be time-based in a Gantt chart form, and you should do a targets, which is the milestone. Then you'll have the project methodologies, how you do your project, what program you are using in your project. You use simulation, you use MATLAB, you use other projects. The methodology should be clarified from the beginning. So you know what you are going to deal with when you distribute the task. You need to know who can do this and who can do the other task. Then you will have to see your budget for the project. You need to wisely distribute the resources on the applications. Then you'll have to see the resources available in your disposal. What are the available resources for your team? The softwares available, the data available, references available from literature, and so on. What are the available? You have to gather all and see, can you achieve your goal with these resources or not? Then you'll have the schedule. After you know what you want to do clearly, you have to do the schedule, which is time constraint in the form of Gantt chart. Then you will have the quality requirements. So usually in any project you have QC, then you have QA. QC is the quality control of the process. When the process is done, there is inspection on the process. So you need to do the inspection. This is quality control. QA, quality assurance. You need to plan how this quality will maintain, how you maintain this quality throughout this process without dropping it. So what are the quality requirements for your design, for your project? The stakeholders and the customers. So basically in Capstone, you have your supervisor is your stakeholder. So he will tell you what he wants. But in engineering, in general, you can have the stakeholders is the mother company. You can have the stakeholders is the state. The government can employ your company to do this. So they are the stakeholders. They have to tell you what they want exactly you to do. So you need to communicate with them to know what exactly your scope and what they expect from you. Similarly, your supervisor is your stakeholder here. You need to verify in each step. Am I doing correct? Am I in the right track, or am I going out wrong ways? The customer is your target. So the design should be for this customer, no more nor less. So you don't provide additional things that is not needed by the customer, is a waste. Also, you don't do the design with things that the customer is not satisfied. The customer needs this option that you didn't provide for him. So your goal is to do this product that satisfy the customer. So you need to have a survey what customer wants exactly. Then the environment risk and uncertainties. You need to do the environmental study and the risk analysis. Your project is low risk or is high risk. These are parts of your study. Then you'll have the ethics and cultural studies. You should follow the ethics practices in engineering, in delivering your scope, in delivering your goals to the customer. It should be clear, it should be documented, it should be following the ethics, also the cultural values. Then you'll have the standards and law. So if you are following all chemical processes has standards. How to do this process. First do this under ISO standard this, or under, if you are doing air conditioning, so you have ASHRAE standard, you have other standards, European standard to follow. So it's not arbitrary. You need to follow the standards in your design. So your design could be recognized by the authorities, could be recognized by the bodies, the engineering bodies. Also, the law requirement. If there is a law requirement, you need to know about it, like DOSH requirement, safety requirement, police requirement in traffic or something. If you are doing a vehicle, it is required by law to have this. So you need to know what are the law requirements for your product. So tips first for the team leader. These are some advices for the team leader. So first you have to find out what are the strong and weak points for each member of your group and their preference clearly by the beginning. So you need to discuss one by one with each one, how you will do, what you can do for me. I will give you this task, can you do it or not? Or you prefer another task? So it should be a very clear, very transparent communication with each member to be able to assess the risk, the risk taken when you gamble the time. This person cannot do it in time because he is not the right person to do this task. Then you will have to ensure a clear and effective communication between your stakeholders and customers and your project members and yourself. So your stakeholders usually in this project is your supervisor, but in other projects it could be the government, it could be the mother company. They need to specify clearly, and not only through the initial task, but through the task. You go back and forth. Don't allow any confusion. They think you are doing thing and you're doing something else. No. In each process, you need to go back and communicate with them. Is it this one that you want or not? Also, the customer. You need to have very clear vision on the customer through customer surveys. Sometimes the company send the product to our reviewers that are representing the customers, so they can feel the product, can see and can comment on the product. So you need a very clear communication throughout the project, the design process of the project, not by the beginning only, but throughout the design project. So all the team members, you should clarify the objective very clearly, the scope. Everybody should understand, mutual understanding of what you are doing, what you're planning to do, and what is your scope. Keep communication channels always open, not only in the beginning, but during the project, step by step. For each milestone, you need to show, you need to present, and you need to have a communication, two-way communication. So everybody will be on the same page. Lastly, you will have the plan activities in stages. So there are different programs available on the market. Some programs, like one website, give this team projects management. So they propose two types of management. One is the agile, and one is the water flow. So the water flow is, as the name implies, is in series, means you finish one task, you start the other task. But this one, the water flow mechanism could have a bottleneck. If this process is hindered or delayed for some reason, it will have the bottleneck for the whole project. So it will jeopardize the entire project timeline. So the agile one is, rather than having the step in series, one step finish, another step start, you align in parallel most of the projects. So if you need data from your friend, you wait for this data, but meanwhile you can start your process from other data, from literature. You start the calculation, preliminary calculation. Then once you get the confirmation from your friend, you align with your results that you get and you do some minor correction, but you already did the calculation. So you don't wait for your friend to finish for you to start in series, but you start in parallel. You can have the source of data elsewhere. Then once your friend gives you the actual data, then you realign, remodify your calculation to align with the actual one. So this will be mostly in parallel. So you don't have a bottleneck. If somebody got sick or got stuck with some calculation, he couldn't do it, he will not jeopardize the whole project timeline. Other people also can work in parallel. So you need to put deadlines for milestones, because people usually don't work without deadlines. So each task should have a deadline. Also, the milestones should be celebrated with deadlines and with some celebration to complete this milestone. Lastly, you will have to create activity board, as I will show you next. This activity board will organize each task. You know, where is it? Did it start? Is it in the middle? Is it completing? So this board could be shared among the members. So you can have a shareholder, a share folder for the team. You can have some Google Drive or any other share service. So everybody complete his task, he put the documents in this share folder. So once you need the document, you don't go and search for it. Everything is there in your share folder. Everything, all drawings or calculations or meetings, discussions, anything you want to find, it is already in your share folder. This is very good idea. Once you're stuck in some point, you want to revise some data, you don't call your friend, what was that we discussed the other day? No, you go to the share folder and find the document and save a lot of time. So example of the activity board, this one taken from teamwork.com. Not necessarily you do the same as this. This is for their tasks. You can do another naming. So this one start from the left, you have to do. So these cards are to do, are planned, not done yet. So you're planning to do this, you're planning to do this. Once it is completed, it moves right side. To be written. Not necessarily the title should be to be written, you can change it. You can do the first column to do, the second column in progress, for example, the third column waiting for approval, the fourth column reviewed. So the task will move from left to right across these columns. So the team manager and the team members can see at any time in the share folder on this activity board. This task is where, when I expect it to arrive to me. So it is now in the written process or in the approval process already, or still to do, still didn't start it. Now, lastly, the tips for team members. So you need to know your team member, do some activities with your team member. Don't be a stranger, because if you are a stranger, your team members will not care about your status. You cannot complete in time. They say it is your problem. It's not our problem. You need to start having a friendship. You need to start some activities, eating together, play games together, play sports together, bound together. So the tolerance margin between you will increase. If you are late a bit, there is a tolerance. He will not go to the team leader, say, this guy didn't give me the task on time directly, even if 5 minutes passed. He will give some tolerance. He might also help you. Then when you have a spare time, help other in their tasks. If you do that, other will help you when you need that. Sometimes you are down for sickness, or you are busy with some assignment, you are busy with some exam, you cannot do the task on time. So if you help others to do their tasks, you expect others to help you when you need that help. Then weekly log sheet is individual task. You will be given the marks individually. So each log sheet should be completed in time, because this is your own marks. This is not the team marks. If you don't finish it, nobody will be affected, only you. So the marks will be deducted from you. So you need to do it early as possible and show your supervisor. Then he will comment on your log sheet and give you back the comments, and you do the corrections for your weekly task. This is an example from Gantt chart from one of my projects, grants. This separated example of Gantt chart alone and milestone alone. So usually milestone is in the form of completion of something, design completion, documentation completion, economic analysis completion. So it's a big task. So 2 or 3 tasks can come to one milestone. So for the project, you can have 4 or 5 milestones, but you'll have 9 or 10 activities. Another form to do the Gantt chart is this one, I think, through the Ministry of Education, FRGS grants. They do this one automatically online. So this is very beautiful. You have the tasks in the Gantt chart, while you have the vertical lines showing the milestone in each task for each couple of tasks or group of tasks. So this is a combined Gantt chart / milestone in the same chart. It's very useful. You can see the activities and see the milestones in the same chart. Okay, thank you. Hopefully you find this presentation and topic useful.